All right, so as you can see, this one's on nomenclature and formulae. You'll notice here it's one. There's going to be a second part to this, but it's not going to follow on from this section on nomenclature and formulae. I'm actually going to intersperse it with another section. The reason will become more apparent when you look at that other section. So, but let's just get started with a basic introduction to the way in which you name coordination compounds, and you also get your head around the formulae for coordination compounds. Now, as I said before, basically you can indicate the presence of a complex a coordination complex by using square brackets. So we've got this compound here with those square brackets. That's telling you that that's the coordination compound. So when you first look at this, I guess what maybe gets a little bit confusing is what's going on with this bit outside the brackets, and it's not always immediately apparent what the oxidation number for the metal ion is. So somehow you've got to figure all this out. So let's try and get our heads around this a little bit more. So here we've got our friend ammonia. You know that that stuff there, those molecules are not charged. By the way, one thing that's helpful is that it's not always the case, but many coordination compounds have 6 ligands, or at least a coordination number of 6. And you can see here that there's 5 ammonia molecules and there's 1 chloride ion there as well. Now, I guess what makes it a bit confusing is that there's no minus sign on this chlorine here. You just have to know, basically, that when you're looking at these compounds, you should know something about the chemistry of chlorine, that it never gets around as chlorine atoms. They'll be chloride ions. So let's just go back and look at this again. These are neutral. This guy here is 1 minus, so let's put a 1 minus there. Yeah, it takes a bit of detective work, I know. So there's 1 minus there for this guy. Now, what I'm going to do is jump outside the brackets and look at this. Okay, so this is not Cl2 gas. This means that you've got 2 chloride ions here, right? Um, uh, how do I know this? Well, it's just a little bit of practice, actually. Generally, these coordination complexes will have a charge. They don't always, but they often do. And it's not unusual for that charge to be a plus charge. It's also not that unusual for it to be a minus charge, actually. But these chloride ions here are actually the counter ions, right? So they're the counter ions to this complex ion here. So if these are chloride ions, the total charge for those guys is 2 minus. So the total charge for this complex must be 2 plus, so they balance each other out. Okay, so we're almost there. I know it takes a little bit of practice to get your head around it. So let's go back to here again. So we know this is a chloride ion here. We know the overall charge of this is 2 plus, so the oxidation state on this cobalt must be 3 plus. Now let's just check it all again. If this is 3 plus, this is 2 minus, the charge on the overall complex is 2 plus, and then I've got 2 minus for the total charge on those 2 counter ions there. So overall this is electrically neutral. I think you can see here that we've basically got an ionic compound. This compound here, what you'd be familiar with in first year, it would be something like an equivalent in first year when you're looking at stuff would be something like calcium chloride. I mean, you write that formula there, but you know full well it's actually 2 plus, and we've got 2 lots of 1 minus there, making the overall charge neutral. So this is an ionic compound where the cation, if you like, is now a complex ion, this guy here. And yes, I know that it's not easy and immediately obvious sometimes to figure all that out, but that's the trick to this, right? It takes a little bit of time when you're looking at it to figure out what's happening. Okay, um, uh, let's just look at these dot points down here. You can see dot point 3. Got for a complex ion, the charge is written outside the bracket. So when I'm writing the actual formula for the ion itself, of course, I have to write a charge on it. But when it's in the ionic form here with its counter ion, the charge isn't written. So that's equivalent to that convention there with, say, calcium chloride. There's no charges written there. They're implied. You have to figure it out. Now, don't blame me. That's the way it is, right? And I've got here just as a little note for you. Most coordination compounds are ionic. Not all, but most. And again, you have to figure it out. That's the tough bit. Okay. Now that's the formula. What about the name, right? So the naming convention, we'll get into more detail in this later, but I just want to give you a bit of a heads up. The naming convention is that you name the cation first, followed by the anion. And as with compounds like this, you don't actually indicate the numbers, right? So in this case here, this thing, we'll get into this in more detail in a moment, would be this name here, chloride. You don't say dichloride, it's just simply called chloride. Again, you've got to figure it out if you've got just the name here. Okay, so how do we name this? Well, we've got 5 amino groups. Now, it's not called pentaamino. The naming convention is these ammonia groups. The ammonia groups are named amine. So this is pentamine. So you name them first. Then the chloride, in this case, the convention is it's called chlorido. And then you name the metal ion. In this case, it's cobalt. Then you give the oxidation state for the ion. In this case, it's cobalt 3. So here we are down here, a little explanation again. We've got 5 ammonia ligands, 1 chloride ion ligand, and the cobalt is in the 3 plus oxidation state there. And so you could start with the name and work backwards and figure out it's that, or you could start with this and then go in this direction here. Note if you start with the formula and go in this direction here, you do have to figure out the oxidation state because it has to be written there. Because without that, you can't figure out what the formula is going from the name back to the formula. Okay, last slide for this one, and then we'll get on to something else. The bottom line when you're doing all of this stuff is you need to take your time, right? There's no point going at it like a bull at a gate and expecting that it's just going to be everything's laid out in front of you. You've actually got to spend the time to think through what's actually happening with a particular formula. Just to add insult to injury a little bit, it's not always the case that people play fair and write down a coordination compounds formula with the square brackets in it. If it's got square brackets in it, it's a dead giveaway. It's a coordination compound, but often people don't do that. So what they do is they'll often write down the compound's empirical formula, or they'll actually write down the linear or condensed formula. So what that means is they'll leave the square brackets out, and they might, for example, with this guy, write it, I don't know, something like this, but maybe with 3 chlorines. You just got to be a little bit careful. Um, and sometimes it takes a little bit of fishing around to certainly figure it out. Um, the other thing is some people don't play fair either when it comes to naming the compounds. Sometimes their name is trivialized. In other words, people have used the name, their compounds that have been used frequently, and they end up getting a name where it's not, again, immediately obvious that the thing is a coordination compound. So just be aware of that. Excuse me. Um, the last thing about this is just because it may actually look like a coordination compound because it looks quite complicated. Um, it may be, but it could be that the compound is actually ionic, right? And it just simply contains polyatomic ions. And again, it takes sometimes some thought, and in some cases, you've actually got to look that compound up and do a little bit of investigation to figure out what's happening. Okay, we're on to the next section.